Welcome back. Hey, so this is video number 2. The topic is what will be needed. We're not going to go through all the basic things like drill bits and drills, and I'm not going to bore you with all those things. If anyone has a comment or a question about what is needed for tools and things like that, I kind of had some of that stuff in my overview video, but basic hand tools and things like that. What we're going to be going over is the SD card that you need, because it's kind of important to get the right one, and the G code and M code commands along with the macros that we're going to be setting up. This is to give you a basic understanding of the G code commands and M code commands and things to get you ready for the physical setup and the programming side of things. So this is the first part of the deep dive, if you will, before we get too deep into this stuff. So just kind of a preliminary go over, get you guys set up, get you a printable for all the commands, or you can take a picture with your phone of the screen. I'll have up on here the G-code commands and things like that, so that you guys can have that at your fingertips. So as we go through things, you can pause the video and reference these G-codes with their descriptions to kind of understand what I'm talking about. So this is where everybody kind of falls off the deep end and gets scared about purchasing an automatic tool changer and all these commands, right? So the process is not that hard. It's just a little bit of a learning curve. And so if you're not afraid of a little learning curve, you're going to learn some really cool stuff. You're going to turn yourself from a hobby CNC guy to more of a CNC type operator and be able to do some more advanced commands here. So it's not that bad. So stick with me and we'll go through this. So let's start out going to Amazon. We'll start out with the mini SD card that we need. So let's go to Amazon.com and let's just search Amazon. Let's just do a mini SD card 32 GB. So you only are going to need one of these mini SD cards, and let's see what we can find. So here's a Lexar. I don't think it matters what brand you go with. So I think I had an ONN, ONN, I believe is the brand that I went with. A lot of people like these SanDisk ones. These seem to be the best ones, but you can see $8.69. They're pretty cheap, and we don't need a big one. In fact, the 32 gigabyte is as big as you can go without having issues in your control board. So in the Super Longboard EXT, there is an SD card slot that you can put this in. So if you haven't ever worked with a mini SD card, watch some other YouTube tutorials about how to put them in and how to work with them. They're tiny, and you put them in and they work. So you will be taking this in and out of your Super Longboard. So you're going to need, if you're going to use the G panel that comes from CNC Labs, that does not have a mini SD card reader built into that. And it also doesn't have a regular SD card slot for you to put that into. So you're going to either need a USB to mini SD reader of some sort to be able to plug that in so that your computer can read it. Or if you're using a different laptop, like the laptop that I'm on right now has its own SD card slot. And so this mini SD card here, let's just go up to this one. This mini SD card plugs into the SD card adapter so that my computer can take these bigger ones, and I can slide it right in, and then I can go on the RapidChange website and I can download the macros and things that I need right onto this, and then I can pull my mini SD card out of there and put this back into my Super Longboard EXT. So this is, you just want to have the most basic 32 gigabyte Max size, you could do a 16 gigabyte, an 8 gigabyte. If you have something laying around from years ago, you can use that. Just don't exceed the 32 gigabyte. I've had lots of issues, and I've heard of other people also having issues with anything larger than a 32 gigabyte. It just, the super longboard will read anything bigger at random. So I don't know if it just doesn't have the capacity or the memory to read through that large of a size mini SD card, or what the problem is, but just get a 32 or less and you'll be fine. The more basic, the better. And then what we're going to do is you're going to want to put that SD card in. This is an optional step, but this is what I did, is I plugged that into my computer, and in the computer, when it comes up, it's going to have, you're going to find it, you know, on off of your C drive. You're going to right click on it, you're going to click format. It's going to give you an option to do a quick format or uncheck the quick format option. So I unchecked it and I did a regular format for FAT32, and it took about, I don't know, 20 minutes or so to format that. And then once it was formatted, you can rename what it's called. I think I just called it CNC Labs or something like that. And then I was good to go. I haven't had any issues since. So this covers the SD card portion of this video. So moving on to the G-code commands and macros and things like that. So we're going to go into Microsoft 3. I can't switch web pages here or I'll lose my recording. So I'm going to try to get into this. So let's go Microsoft. Let's just type in 365 and see what happens, because I have this on 365. All right, so I am in here. So a quick tip for you guys, a little bonus here. If you don't have Microsoft Excel, Microsoft Word, and all of these things, don't worry, because you can go on to Microsoft 365. If you have a Gmail account or whatever, you get this for free. You just go into Microsoft 365 and you set up a free account, and you can use spreadsheets, Word documents, PDFs, all this kind of stuff online. So you can't use it when you're not online, but as long as you're in Microsoft 365, you can use any of these things, you know, Word documents and all that, and read them and use all this stuff for free. So you don't have to buy the Office package for hundreds of dollars, you know, to have it on your local computer. So anyway, here's my sheet that I created for these. So I'll just try to, let me try to get this where you guys can take a screenshot. So there, so I'll just leave this up here as we go through it. Feel free to take a shot with your phone or a screenshot, or if you're watching on a TV, just take a picture of it. That'll give you a reference to these things. I will try to attach a PDF of this in the description of this video. I'll also copy and paste what you see here in the description as well, so that you have access to this. This is my best ability to try to explain all the commands that we're going to be using. There are many, many, many other commands out there that can be used for many other functions, and it gets deep. But these are just the ones that pertain to what we're going to be doing to help you fully operate and understand your codes and your programs that are going to be created from RapidChange ATC. So going through, I'll just go right down through the list here. M code commands. So M0, literally the letter M, the number 0, that will pause the program. So typically, if it is in the middle of a tool change, so M code commands are macros. When you're in the middle of something, you can literally pause whatever program that it's running. And you can enter these manually. The only one that I really ever enter manually, well, there's two of them, is the M6 command, which that's funny, I don't even have this on here, so I'll add it as we go here. I enter the M6 command, and I enter the M61 command to assign the tool to the spindle. So, and I'll kind of go through a little explanation of that as we get there. So M99, these are just, you're going to see these codes if you were to open up the macros that we get from RapidChange, which I'm going to go over in video number 4 when we get into programming. They're going to be referencing, there's going to be a bunch of these G-code or M-code commands in there along with G-code commands. So this is just your quick reference guide to be able to reference these, to know kind of what they're doing. So if you see, a G command with an M code command, you can kind of look at the descriptions and get it in layman's terms of what that programming is talking about. So the M commands and G commands are the computer language. So these are the descriptions of what they are. So you can enter these manually in the command prompt, or these are just part of programs that are automated. So it's not something that you have to use all the time, but some of them you will. So M99, when you see that code, that ends all current running codes. So sometimes in these macros, you have multiple little programs, if-then statements, and different things like that. So in order to end that and move on to the next series of programs in that macro, they do an M99, and that basically tells the computer to stop everything that you were working on previously, and it just clears that, and then it gives it the next command to start whatever the next set of, programs or assignments that it's trying to tell it to do. Otherwise, sometimes you can get a couple things running and it can mess it up. So it's very linear, and it just does exactly what you tell it to. M3 commands is turning the spindle on clockwise at a certain speed. So in this example, M3, S for speed, M3S 1500 turns the spindle on clockwise at 1500 RPM. Okay, pretty simple. And you can do this manually. You can type in literally what I have highlighted here in your command prompt to test to see if your spindle even turns on and is working as far as testing goes. Type in M3S 1500 and that will turn on your spindle at 1500. Now, if your spindle cranks up to 20,000, that means that in your VFD settings, your minimum speed is probably set to 20,000. And either you'll get an error code or it just won't follow you. So that's where your testing comes in and trying to understand what you have programmed in your VFD, which we're not covering here. But that's just something you can use in your testing. And then to stop the spindle or to turn the spindle off, you just type M5 in the command prompt, hit enter, and that'll turn it off. So if you turn it on with M3S 1500 and you want to turn it off, you just type in M5 and hit enter, and that'll shut your spindle off. Then if you want to test it counterclockwise, you can go to M4. An example, M4S 1800 turns the spindle on counterclockwise at 1800 RPM. So where that's used is you got to go counterclockwise, obviously, to remove your collet nut in your collet tool. And they increment it automatically by 300 RPM when we set up this when we set up the macros in the RapidChange web UI. So that's online on the RapidChange website. When you purchase your RapidChange, you'll get that code, an activation code, and then you'll be able to use their website to create your macros, and that automatically makes all these programs for you. Super, super nice. So here we go. You turn it on M4 counterclockwise, 1800 RPMs. You verify that your VFD is telling it to go 1800. It is going 1800. Everything is good. Type in M5, hit enter, and that'll turn your spindle back off. Okay, so those are some manual ways to use those codes, but otherwise these codes will be in the macros, which are the sub-programs that we're going to be putting on our SD card, and within series, it's going to automatically tell it to turn it on and turn it off and stop it, and go counterclockwise depending on what function it's doing when it's doing tool changes. Okay, so M8 is your coolant flood. So in The Super Longboard EXT and G Sender, you will be able to find in your firmware your coolant buttons. There's little toggles in there that you can turn on and off, and you can do settings for them in your firmware, and we'll be getting into that again in the programming section, video number 4. And so you'll be able to do this manually as well. So if you want to test when you get things hooked up, you can literally type in M8 into the command prompt in GSender and hit enter, and you should be able to see your dust cover open up. And then conversely, you type in M9, hit enter, and you should see your dust cover close. And if it doesn't work, then that means it's not going to work in the programs either. So that's where you'll be able to use those codes to troubleshoot, to make sure that you have settings right before you try to run a program. And because the last thing you want to do is crash your bit into your dust cover, right? So you want to make sure that these codes are working and you have things connected right, and different settings in your firmware settings and things are going to be very important when we get to that, to make sure you have them set right. And it's going to be a super easy to follow along video number 4, to set that all up and then do the testing, make sure everything is running. You can manually open that dust cover, or you can also just open the cover by hand by flipping it open, or just don't even put the cover on, but you'll be able to hear the motors trying to open up or close the dust cover. So I left my dust cover, the physical clear plastic cover, I left that off during all my testing so that I didn't accidentally crash a bit into the dust cover and ruin it or anything like that. So that's just a quick tip. Okay, moving on. M61 is a sign tool to the spindle. I use this all the time. So there's a couple of reference codes here. So you're going to reference G code 65, G65. So G65, which we're going to get into right down here. I guess I'll do these together. So with G65, it enables calling an M command subprogram. So these are the macros that you have set on your SD card. So when you type in the command prompt, G65, and then whatever macro, which is down here. So this one I use all the time, P203. These are the macros that are created on the RapidChange web UI. These are all the macros that it creates. And if you type in G65 P203 in the command prompt, it's going to show you what current tool is assigned to your spindle. So whether that's 0, which means there's no tool, or if it's tool 4 or it's tool 1, it's going to tell you what tool it believes is in the spindle. And then you can either just manually put that tool in and make sure that that slot is open on your tool changer, or you can also change it with a G-code command, or using this M61 command, you can also change the tool. So if your machine thinks that you have tool 1 and you do this G65 P203, which tells you, what tool you have assigned, and it shows that you have tool 4, well, that's not good, because you're going to crash into your thing because your program doesn't know exactly what tool you have in there. And that could be because of a number of reasons, whether you manually put the tool in or whatever, but you got to make sure that your machine knows what tool it has, right? So this is how you assign that tool. So if you manually put a tool in for whatever reason, or you're just playing around and you're typing in the M6 commands and doing tool changes, but then you turn your controller off and then you turn it back on and you rehome it, my machine, when I turn the controller off and back on, it resets to 0. So if I have a tool in the spindle, it doesn't remember that. And so that's something that I'm hoping that CNC Labs, I think I have a message out to CNC Labs to change that. So just like your homing functions, so when you home your machine or you turn your controller off, it remembers what your Z0 was. It maintains that, and it knows what your Z0 is. But for some reason, for the tool changes, when you reset your controller, it automatically resets it back to 0, and it doesn't remember that. So that's something that CNC Labs is working on. But for now, you always have to check. If you turn your controller off and back on, you're going to want to assign whatever tool's in the spindle by typing M61Q and then whatever the number is. So if you want to assign tool number 1, it would be M61Q1. And then you hit enter, and then on the command prompt it'll come up and it'll say, assign, tool number 1. Or if it doesn't say anything, you just type in that G65 P203, and that's that macro on your SD card that is going to tell you what the machine believes is in the spindle. So you assign tool 1 using M61, then you type in G65 P203, and then you'll get a message that'll come up on your command prompt telling you what tool is assigned. That's how you can verify that. I use those all the time. So while we're here, I'm going to add in the M6 command. So M6 is tool change, and then example M6T1 is changing to tool 1. So the program will, unload current tool and load tool number 1. So if you were to type in, let's just say you typed in this G65 P203, and your command prompt tells you that the assigned tool is tool 0. That means there's no tool in the spindle. And you type in M6T1. There is no tool to drop off, so it's just going to go and pick up tool 1 right away. So if you have, say, a tool in your spindle, say you were surfacing your surface board and you got, your surfacing bit in there, it's going to literally go over to tool 1 and try to load tool 1. And it's going to crash your surfacing bit right into the top of tool 1 when it's trying to load it, because the spindle doesn't know that it has your surfacing bit. So you'd have to manually take out your surfacing bit if you had it in there, make sure you have no tool in there, and then do T1. So once you get T1 in your spindle and it does its thing, and now it's good, you could double check by doing a G65 P203, and it will show you then that it picked up tool 1, and the tool 1 is now in the spindle. And it'll tell you that right in the command prompt. So that's how you can verify. And then you could type in, say, M6T2, and that would then, because it has tool 1 in the spindle, and it knows that, it's going to go drop off tool 1 before it goes over to pick up tool 2, and then touch it off and measure the tool. So hopefully that kind of gives you a basic understanding of how that works. So moving on here, I can't remember if I went over M8 and M9. M8 turns your coolant flood on. M9 turns your coolant flood off. That's to open or close your dust cover. I think we went over M61, and now we're into G-code commands. So I'll stop here so you can kind of take a picture of this section. So G4 is the dwell pause command. So I don't ever use this one manually. This is just part of the program. And what it does is when it's going to start to do something like, say, it picks up a tool, it's going to give you a G4 command to dwell or pause for a second before it goes on to the next thing, right? So if you were to type in G4 P5, nothing's going to happen. It's literally going to pause your spindle from doing any XYZ movements for 5 seconds. So G4 P5. This gets confusing if you look online. There's a lot of different machines out there for many, many years that use the G4 dwell command, and a lot of other machines use the P, G4P, as the milliseconds. But in Gerbil and in this scenario, the P is used for seconds. So typically S is used for seconds, but for all intents and purposes, all you need to know is that the G4 P5 command would pause the spindle from moving anywhere for 5 seconds in a program before it moves. So that's really all you need to know about that one. G53, you'll see this in the programs when you're looking at them. So G53 is your predetermined location that you're going to set when we do our setup in the RapidChange web UI. And you're going to manually move your spindle and your bit to the location of your tool setter. And you're going to document that X and Y coordinates for that. And that's what you're going to put into the web UI, which we'll get into in video 4. And when you set that in that, it's going to put that into that macro program for your tool change program, which your tool change program is right here. TC is tool change. So this is the main program macro that uses for tool changes. And so G53 is used so that that program knows where you're setting your tool setter, and so that it can go there and do its touch-offs. So very important code there. I don't ever use this manually. It's only part of the program. So just showing you for familiarity. G90 is also part of the programs. So there's G90 and I believe G91, if I'm not mistaken. We don't use these manually. This is what tells the computer in the macro to use absolute coordinates. So in GSender, there are 2 different coordinates. There's the bigger ones in blue, and then there's the smaller ones in gray. I believe they're gray. So the smaller ones in gray are your absolute coordinates. Those never change. Once you home your machine, it's going to have all your absolute coordinates. Your blue coordinates are your reference coordinates from 0. Or from your absolute coordinates. So when you set your Z height for your material, that's a reference from your Z0 homed location to that Z height. So this just tells the computer to use absolute coordinates. It's not using reference or relative coordinates relative to your absolute coordinates. I don't know if that makes sense, but you don't really need to worry about it. It's all pre-programmed in there, but you're going to see the G90 codes in your program. That's all it means, is that it's telling the machine, make sure you're using absolute coordinates and not the relative coordinates. So I guess the only other thing I could say about that is it's important to understand that when you are setting your X, Y, maybe and Z coordinates for the macros, when we get into that in video 4, you're going to want to be using those little gray absolute coordinates, if you will. So don't use the big blue ones, coordinates. Use the absolute coordinates, which are the gray coordinates for all of your setup. So that, because that's what this program is going to be using, is those absolute coordinates. G0, this tells your machine to move using rapid moves. So again, we don't use this, so this is used in combination. So if you did G0 and then put an XY location on here, it's going to move to that location using a rapid movement. So you could enter that manually if you wanted to go somewhere, and it would use absolute coordinates. So if you, for example, you would say G0, because you're going to want it to move in rapid movements, and then space G90 to use absolute coordinates, space, and then give the coordinates you want it to go to, hit enter, and it's going to go to that location in a rapid movement. Okay, so that's kind of how they string these G codes together. We're never going to be doing that, but that's what you'll see in the programs. G43.1 is use the tool length offset. Again, you're going to see this in the codes. We're never going to use this. So this is when it goes to your tool tool length tool setter, It's going to use this code to reference what the previous tool was touched off to the new tool that was touched off, and it's going to reset that bit height so that it knows exactly how to get to Z0. So if your second bit that you put in is shorter, it's going to adjust that so that it knows to go further down to get the tip of the bit to the Z0 material height location if you set your program for material height. Okay, so we're not going to use that manually. That's just part of the programs to help your understanding of how things work. G20 is using inches as the unit of measurement. So again, in a string of commands, if you were going to use G0, G9, space G90, space G20, space, and then put your X coordinate, space, then your Y coordinates, it's going to tell the machine to go using a rapid move. I want you to use absolute coordinates, and I want to use inches of measurement to move X to a positive 24 and a Y to a negative 24 location. And then it's going to move to that location using those measurements. Now, if you wanted to do that in millimeter measurements, you would simply put in G0, G90, G21, and then put your XY dimensions for your X and Y location in millimeters, and then it'll move there. So if you put 1,000 millimeters, I don't know how that computes to inches right off the top of my head, but it's going to move in whatever millimeters you set it. So if you put it to 24 in the X and a negative 24 in the Y in millimeters, it's only going to move to the millimeter locations on your machine. Okay, we're never going to really use this. You could use it manually, certainly. So a lot of advanced CNC operators out there, they can manually put these G codes in just from memory because they've done it for years. But we're brand new into this, and we're not going to be doing all this stuff manually. We're going to be using the automated programs from RapidChange ATC that they've made to make it super easy for us to do it. This is just to give you an understanding of how G codes work. Okay, very, very, very important here. This is one of the major bugs that we found in going through for the alt mill and G-Sender. One of the main issues that G-Sender is having with a lot of programs, it's not the G-Sender that's having the problems necessarily, it's the way that we're setting things up and what we're changing for settings as users. So there are two settings in the G-Sender software that you can set millimeters and inches. There is a firmware section. So if you look at G-Sender and you look at the top, there's going to be a firmware button. And you type in that firmware button, and somewhere down around, I think it's like number, $13 or, firmware number 13 is where you can toggle on for inches or leave it off for millimeter measurements. Always, always, always leave your firmware settings set to millimeters. That is the default for G-Sender. Most programs, this was G-Sender is made in Canada. They use the metric system, and most other countries other than America use the metric system. And so that is what you need to keep G-Sender set as. If you want to see your G-Sender settings, maybe not settings. If you want to visually see your X and Y and Z coordinates in inches, you will go to the gear icon on your main G-Sender interface. There's a gear icon in the top right. That's your preferences tab. And you can click on that, and in those settings, that's where you can change to inches to display things in inches, and that's okay. But the firmware, so when it's running programs and everything else, all the programs and all these macros are all using millimeter units of measure. So we need to keep the firmware set at millimeters. Otherwise, you will have major issues and you won't be able to do anything. And you won't understand why, but that was the one setting that I had changed to inches, thinking I need that to inches so that I can see everything in inches, but that's not the case. If you have any questions on that, leave a comment in this video. I can help explain it further, but just leave that firmware setting to millimeters. Okay. G38 is used in programming, so you got 38. G38.1, G38.2, there's a bunch of different ones. The only one that we're going to really be using that I'm aware of is G38.5, and that is used along with other commands to send the tool Z down to touch off. So it'll use a G38.5 with a G90 for absolute coordinates, with a Z coordinate that it'll want to go, and it'll actually use a relative, so it wants it to move like so many millimeters, and then it'll put an F for the feed rate, and then it'll put the feed rate that it wants to go down to touch that off. All that is automatically set when we do the web UI on the RapidChange website. So nothing you need to know here other than G38 is what is used for the tool setter to tell your spindle or your Z-axis to move down and touch off on the tool. So that's what that is used for, but it's all automated. So that's just a reference. Okay, moving on. Macros on SD card. So these macros are in order currently as of this video. This is the order that they have them in RapidChange on their web UI. These are all their macros that are going to be created automatically when you put your settings in there. We're going to go over all this stuff in programming, video number 4, when we go on the web UI on my account, and I'm going to walk you through how to set all these things up for your program. Okay, you will get a lot out of that video. That's going to probably be the main video. So the next 2 videos coming are not going to be, web type of videos like this. They are going to be, you're going to see my face. We're going to be moving the camera around. I'm going to be showing you stuff real time, and we're going to be going over physical setup and programming together and show you exactly how to walk through all this stuff. Okay, so these are the different macros. So TC is your tool change macro. That's your main tool change. So when your program, if you put a program and you export it and save a tool file, or save a file from Vectric or VCarve Pro, which is what I use, it's going to have M6 commands built into the program. And that's all it's going to do is put an M6 command. And what that M6 command does is it tells GSender, oh, we're going to do a tool change. And then it's going to look for the subprogram here, macro, and it's going to look for this tool change macro. Okay, so it's going to put in probably a G65 TC command, or maybe it's just an M6 command, but either way, it tells it to look for this tool change command on your SD card, and it'll open that up behind the scenes, and it'll automatically go do your tool change. So that's where it comes into the post processor. So RapidChange has created a post processor for the alt mill. We've tested through it, works flawlessly, everything works great, fully automated, and you won't need to know anything. But if you were to open up this macro, once you download it, we'll show you all this stuff. You open this up, you're going to see all those other G code and M code commands that we just went through in this as G code lines, and so you'll be able to kind of decipher what this is doing. You'll be able to read some of the G code in there now that you have this quick reference guide here. You'll be able to reference what, in sequence, what this thing is trying to do. It's still going to be confusing, but you'll get kind of a gist of it by having this documentation. So P208 is basically opening the cover, so it's going to do an M8 command. P209 is going to close the cover. That's basically a M9 command. P231 is measure your current tool. So if you typed in G65 P231, it's literally going to send your tool. It's going to move it up to Z0 or to your Z home location, and it's going to move X and Y to your determined location where your tool setter is, and it's going to touch off that tool and measure it. So that will make it move. So you can do all of these manually by typing in G65 and then P208, P209, and it'll automatically do these things with that G code. Okay, these are the commands, and it'll be reading them off of your SD card. All right, so P231, measure current tool, so we just talked about that. P200 is find Z position. So this is a setting that you will use before, so you'll be downloading the, that macro particularly, and putting it on your SD card in the setup process to find your Z position using the sensors on your tool changer. So if you didn't get the tool changers with sensors, with the optical sensors on them, you won't need this. You're going to have to manually find that, and there'll be other instructions on how to use that and find your Z position. But this is used with the sensors. And then P201, P202 I've never used. It just says before tool change, after tool change. Those are programs that are automatic, automated when you do a tool change. And then P203, we've talked about this one already, G65, P203, you type that into your command prompt, hit enter, and it'll show you what current tool is assigned to your spindle. Okay, that's a lot of information. Don't worry about it. This is an overview and a reference for you to have while we go through the programming and using the G-code commands. So study up, print this out, have this at your fingertips when we get to video 4, or maybe even we'll do some of this in number 3. We'll see. But this is going to really help you out a ton, having this at your fingertips so you can reference these things, pause the video, and try to understand what I'm talking about when I'm talking these different G-codes. Okay? So the only other things that this video was going to be about was, having the automated controlled spindle, or if you don't, extra bits and collets and nuts. So make sure you have extra collets, extra nuts for your collets and things like that, so that you can, change tools and all of that. If you only have one nut and you got 3 collets, well, you're going to need more nuts. So whatever you have, if you have an ER16 that comes with the CNC Labs spindle, you're going to need to order on Amazon. You can easily go on Amazon and order new collet nuts and order a bunch of them. And then same thing with collets. If you are going to have multiple 1/4-inch bits or multiple 1/8-inch bits that you're going to want to load up into your tool, you're going to need more 1/8-inch or 1/4-inch collets to match up with your nuts. So you don't need anything super specific. Just pick what you think is going to be a good quality, decent one, and go with the flow. See how it works. I think that takes care of it for this video. Thanks for coming along. I hope this really helps. And get ready for video number 3. I'll be working on that as soon as I possibly can to help you guys get your physical setup on video number 3. Don't forget to hit that subscribe button, hit the notification bell so that you can see when my next video, my next 2 videos come up. Have a great day. Happy Father's Day. It is June 15th on Sunday. Happy Father's Day to all you fathers out there. Take care.